Okay, so looking at these next two together, we have single layer water and thin translucency. Now both of these are types of translucent material that have a little bit of optimization or some unique features in them. And so here we have single layer water. It's specifically designed to do a one-time translucent layer. So we talked about this with the translucency earlier. Obviously changing it to surface translucency volume was an expensive way to do this. This is a more optimal version of that, or a cheaper version of that. Basically, it won't layer the translucency, so it will render the scene and then it will render the water and then composite the two, but it won't layer multiple layers of water on top of each other. And if we just duplicate that and bring it forwards, you can see how we should be able to see the back or the sphere behind, because this is translucent, but we can't because it's only rendering a single layer of water. Generally water is going to be flat, it's going to have one surface, big optimization to not render it as translucent, and therefore we can afford the parts of the material that make it work nicely, so the roughness and the normal map. So rather than changing to an expensive shading model, so I compile this, will actually give me some values, but rather than changing to a more expensive shader model, it's giving us a still quite expensive but more optimal version compared to a translucent lit surface translucency volume. I'm going to give that a sec to compile. Yeah, for dealing with the water surfaces, check these numbers are lower. They should be. No, they're not. Okay, fine. Well, it might be a more expensive material designed to be a more accurate version. Yeah, that's what single layer water is doing, is it's taking a single layer of the material and just rendering it once. It is giving us a higher value. As I said earlier though, these values aren't necessarily explicit, so not every instruction is made equally. So even though you're doing more instructions, they could be cheaper instructions, so it may end up being overall cheaper despite being a higher number, which I appreciate isn't necessarily the most useful when you want to compare your costs. But if you are getting hardcore into optimization, worth comparing the two. But this is designed to be water, so it should be more optimal, but always worth double checking these things. And yeah, so it gives a single layer of translucency that's then rendered as a separate thing and composited together. The last sort of individual blend mode is thin translucency, not blend mode shading model, it's thin translucency. This is a more expensive version, but it's used for things like colored glass, and so it has its own output, thin translucent material transmittance color, and there's a really good example in the documentation. And so this is the sort of standard translucency shading model, so a blue sphere, and we're getting white highlights, and the background isn't really tinted blue, and then we compare it with this, and this would be kind of your Christmas bauble type thing, a blue glass sphere where you're getting now the background being tinted correctly, and then you also get better highlights. You can see making a huge difference in the rendering of those two things. Thin translucency though, much more expensive. So if we change this back to lit, don't need this. I'm going to do my comparison again and hope this time that the numbers support that this is more expensive. Should at least be this way around. But as always, when you're doing optimization or you're checking the performance, do just check your scenes before and after and do your side-by-side comparisons. This is going to take a while to compile. So forward shading, not one we covered. Forward shading turns off any of the deferred features. It is the most expensive. Every light contributes to the pixel being rendered individually, as opposed to with deferred rendering, the lighting is all done in a single pass, and allows lots of a lot more control, or a lot more light to be used. This is, there we go, very, very high, using the forward shading. Often used in VR, because the deferred lighting in VR is even more expensive, but I don't have a load of experience in VR stuff. But if we then bring in a thin translucent output, change this to thin translucency, and then we can plug that colour in and we get our result. So a more expensive but more accurate way of doing kind of coloured glass and things like that.